This video is on simplifying radical expressions. I kind of thought we already did this. I actually looked for the video and apparently I never made one. We just did it in class. So real quick, we're going to talk about simplifying radical expressions. A radical is another word for a square root. It looks like that. So when you want to simplify a radical, you want to break it down into its prime factorization. So things that go into 60 are 6 and 10, and then 2 and 3, and 5 and 2, and right now you're like, oh yeah, we did this. Okay, but we're going to get into more complicated stuff. So you have a pair of 2s, so a 2 goes on the outside, and what's left over is 15 underneath. We haven't really talked about what to do when there's variables, though. So if we have the square root of 18a cubed b squared c to the 6th, well, we're going to do 18 separately. So 18 breaks down into 9 and 2, 3 and 3. So 18 is 3 root 2. A cubed is a times a times a. Well, the same rule applies. Take out the doubles, put 1 on the outside, and whatever's left over is underneath. B squared, if I wrote b and b, I would take out a b. So now I have 3ab, and then I have a root 2a. And then for c to the 6th, if I wrote down 6 c's, there would be 1 pair, 2 pairs, 3 pairs, so I'd have a c cubed on the outside. What it breaks down to is if the exponent on the variable is odd, then you're always going to have 1 left over underneath. If it's even, then your square root is going to be half of the exponent. Let's do one more example. 120 c to the 4th, b to the 9th, a to the 12th. So again, 120 breaks down into 12 and 10, which is 4 and 3, 2 and 2, 5 and 2. So the prime factorization is 2, 2, 2, 3, 5. I have a pair of 2's on the outside, and I'm going to have 2 times 3 times 5 underneath. C to the 4th is c times c times c times c, so 2 pairs. So I put a c squared on the outside. B to the 9th is 9 b's. And hopefully you recognize there'll be 4 pairs, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 pair, 2 pairs, 3 pairs, 4 pairs. So I take out a b to the 4th, and there's 1 left over. And a to the 12th would become a to the 6th. So that's how that one would simplify. We also have to know how to do like a 5th root. A 5th root of 64, a to the 6th, b to the 10th. So for this one, we're still going to do the prime factorization, and I know that 8 is 2 times 2 times 2, 2 times 2 times 2. So I have 6 2's. When it's a 5th root, I have to take out groups of 5 of them. Think about it. When it was a square root, we took out pairs. When it's a 5th root, I take out a group of 5. So I took out a group of 5 2's, so I put a 2 on the outside, and I have 1 2 left over on the inside. A to the 6th, again, I'm taking out groups of 5. 1, 2, 3, 4, 5, 6. Take out a group of 5, put 1 on the outside, I have 1 left over. B to the 10th, if I write down 10 b's, I'm going to have 2 groups of 5. So I would take out b squared. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 groups. That gives me a b squared on the outside. The other thing we're going to talk about is when you multiply radicals, or divide, when you multiply or divide a radical. So for instance, if I take the square root of I don't want to do that. The square root of 12 times the square root of 40. All you do is multiply the numbers underneath. So 12 times 40 is 480. And then do the prime factorization of 480. Oops, 48 and 10. That's an 8. 6 and 8. Wow, my handwriting's bad. I'm trying to do this fast. 2 and 3. 2, 2 and 2. 48 and 10, so 5 and 2. So I have 1, 2, 3, 4, 5 2's. And a 3 and a 5. So I take out 2 pairs of 2's, so I have 4 on the outside, and 2 times 3 times 5 is 30 underneath. You also could have simplified the root 12 into 2 root 3, and the 40 into 2 root 10, and then said that 2 times 2 was 4 and 3 times 10 is 30. Either way, you get to the right answer. I'm more of a fan of multiplying first because I think it's easier to simplify one thing than to say coefficient times coefficient gives me this number, radical times radical gives me this number, because sometimes then you might have to simplify what's underneath. Let's see if I can make up an example where that happens. Root 50 times root 12. So if I do it first, this is 5 root 2, and this is 2 root 3. This is a bad example because I'm not going to have to simplify. What would I do if this was a 6? So that would be root 24. Let's try this. If I do root 50 times root 24 simplifies into 2 root 6. And then if I multiply, I do 5 times 2 is 10. Root 2 times root 6 is root 12, but then I have to simplify root 12, which breaks down into 2 root 3. And then I would have to multiply that 2 by that 10, and this would be my final answer. That's a lot of confusing steps, where if I just do 50 times 24, that gives me the square root of, I don't know, 1220 maybe? Maybe we better check that. 50 times 24, 50 times 24, 1200. So then I could just find the prime factorization of 1200, so I would pick 12 and 100, 10 and 10. And anytime you get a pair, you can stop, because then I'm just going to end up breaking it down into 2525, which would give me 2 pairs of 10. So if you get a pair anytime, you can stop and take that pair out. So I have a pair of 2's and a pair of 10's, which gives me a 20 on the outside and a root 3 underneath. Again, I think this way is easier. You get to pick whichever way you want. The same goes for like cubed roots. Cubed root of 2xy squared times the cubed root of 4xy. Your answer would be under the cubed root, but you would just multiply 2 times 4 is 8, x times x is x squared, y cubed times y is y cubed, and then you would simplify. I know the cubed root of 8 is 2. If you didn't know that, you would do the prime factorization, and you would find that you have 3 2's, and when you take out a group of 3, because it's the cubed root, and then x and x, there's no groups of 3, so that would stay under the radical. And y to the third would be y, 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 so that's a group of 3, so that would go on the outside. So your answer would be 2y cubed roots of x squared. Alright, last thing, dividing. When you divide a radical, it's the same as, it's pretty much the same rule as any division. So the division of 250 x cubed y over the square root of 100 xy. So you can do one of two things. Dividing a radical is the same as taking the radical of the quotient. So you could write it like this if that helps you. So now you can simplify what's inside. 250 divided by 100, well, they both have a common factor of 25. Actually, they have a common factor of 50. 50 goes into 250 5 times. 50 goes into 100 2 times. X cubed divided by x is x squared, and the y's cancel out. Now I would have to simplify this radical, and I would say that the square root of 5x squared over the square root of 2, I'd have to rationalize the bottom, multiply by root 2 over root 2. So this one turns out to be a longer process. So this is the square root of 10x squared over 2, and 10x squared, the 10 can't be simplified because it just breaks down into 2 and 5, but the x squared can be. So it would be x root 10 over 2. Now, let's back up. What I could have done is I could have simplified the top and the bottom separately. So let's see what would happen if I did it that way. The top would simplify into 25 and 10, so 5x root 10y, right? Because I would have 3 x's, take 2 out and put 1 down. I'll leave 1 underneath. And then the bottom, the square root of 100 is 10, and then I would just leave it as the square root of xy. So now I can say 5 over 10 is the same as 1 over 2. That x doesn't cancel with anything, so that stays in the top. This is really the square root of 10 times the square root of xy. That's what it means when you have a number under a radical. You could have just multiplied. So that square root of that xy and that square root of xy cancel out, and I just end up with x root 10 over 2. Now, the whole point of doing this on a video is because I get that that's a lot. I would really like it if you went back and watched each step again and made sure that you understood every step of the process. Whereas if I was in front of the class, it would be really hard to go back and talk you through it again. So I'm going to do one more example. How about the square root of 5x to the 4th over the square root of 2x squared y cubed. Pause it and see if you can get the radical out of the denominator. And when you come to class next, all we're going to do is practice this stuff. I think you have a quiz. It depends on when you're watching this, but check Power School if you don't know. But after your quiz, and this is not on your quiz, this is all we're going to practice. So, root 5 times root 2 is root 10. X to the 4th times x squared is x to the 6th. Y cubed over root 2 times root 2 is 4. Remember, when you multiply a radical by itself, you just get what's underneath. So it's not 4, I lied. It's 2 x squared y cubed. I'm going to show you the justification for that down here, just in case you're wondering. When you multiply a radical by itself, here's what's really happening. It's all under the square root. 2 times 2 is 4. X squared times x squared is x to the 4th. Y cubed times y cubed is y to the 6th. The square root of 4 is 2. The square root of x to the 4th is x squared. The square root of y to the 6th is y cubed. So we just got what we started with, and that's where this is coming from. Okay, so now I have to simplify the top. So root 10 can't be simplified, but x to the 6th can become x cubed, and y cubed can become y root 10y all over 2x squared y cubed. Well, the x cubed and the x squared leaves you with an x on the top, and the y cubed leaves you with a y squared on the bottom. So your final answer is x root 10y all over 2y squared. Done.